Okay, welcome. For those of you who wanted to see Link Voice Interoperability, you're getting an extra freebie, Link Voice and Video Interoperability today with me. Welcome, and I appreciate that you walked so far. Actually, I think technically this must be Texas. Our speaker room is so far away on the other side, so walking from one to the other is quite an experience. So I even more appreciate your being here. And the other reason I appreciate it is that interoperability, I tend to think of it a little bit like accounting. It's one of those very boring but extremely important things. So you're choosing the important and taking the boring. Sorry about that. We'll try and make it a little bit entertaining, but it is what it is. And somebody walking in, oh yes, here he is, was asking me, is this the same thing I heard 2 years ago? And truth be told, it's not that different. There's a lot of new things, but we've not changed our interoperability strategy because it has to be something that's stable, steady, goes across releases, and works for a long time, so we can actually have partners building to it and our customers using it for a long time. So for those of you who expect a completely new interoperability strategy, sorry, that's not the case. What do we want to cover today? Well, one thing I'd like to give you a very brief reminder about is where Microsoft invests with respect to interoperability for Link. Not going to spend a lot of time on that, but from a strategic point of view and from an industry peering point of view, what do we do there? Second aspect, we'll give you an update on practical voice interoperability. And then we'll talk about video interoperability. And for those of you who've played with Link 2013 or deployed Link 2013, you probably know that voice in Link 2013 is building upon Link 2010. There's more, but it's not that drastically different. So what we have new in voice interoperability in Link 2013 is not hugely different. On the other hand, video is very different, and we'll see how that is. So that's the agenda. I'd like to ask you for a favor. Because of the way this is structured, and also to keep us, all of us, awake, if you want to ask questions after each section, now questions on the section itself, not questions on video after we speak about Skype or whatever, but I'd actually welcome that. So if you want to, stretch your legs, stand up, ask questions, we'll actually do it that way, like that, rather than waiting till the end. Okay? Let's get going. So, what do we do in terms of interoperability in Link? First, Link, even though it's extremely successful, is still by and large a relatively small component of the communications capabilities of the enterprise at large, or the enterprise market at large. And so what we know is that we're coexisting, and will be coexisting for a long time, with other solutions in the enterprise. Our scenarios and our approach are built to support that coexistence. Actually, there is nothing that says that coexistence must end. We'd favor that. We'd love to be the only ones, but that's not to the point. Coexistence is intended in the design. The way we go about this is we actually define interoperability scenarios from the start. So we think of which scenarios make sense for our users from a business point of view. Interoperability is not something that happens afterwards just by chance. It's something that we've actually thought of from the beginning, saying, what are the business scenarios our customers are going to need? Well, they have PBXs in place. We're going to come in. What does that mean? They have video conferencing rooms in place. We're going to come in. What does that mean? Those type of things. And not with the intent or with the mandate that this is going to be a rip and replace type of approach, with the understanding that most of you, for investment management reasons or for choice reasons, are going to stay with what you have for a long time. So we actually take this as an engineering project. Interoperability is treated not as something that comes in afterwards, but as a full-blown engineering project with features that are managed in that manner. That includes documentation, that includes all the things that go with that. And then we, of course, work with people that are outside of Microsoft in that regard, both industry alliances. So the UC Forum is prominently mentioned here, but there is a lot of others that we participate in. We also document all of our protocols All the client-server protocols are documented, and they're on the web. And what that means is if a partner or a competitor of ours wanted, for example, to replace our client, but still to use our, let's say, presence engine, they could actually do that quite easily. They could do it not just with the protocols, frankly. Doing it with the protocols is probably a little bit extreme, but they could also do it with the APIs. And all of that's documented, and that's something that is part of the interoperability that we envision when we build the solution from the start. And then we have programs that we manage, and I'll tell you a little bit more about that. Those programs are testing programs. They are vendor and partner management programs. And we, of course, make all of that also available on the web. I'll show you a little bit more in a second. So to talk specifically about that last point, those UC open interoperability programs, there's actually 5 of them, or 5 pillars to that. Audio and video devices, infrastructure, which is a huge pillar, covers PBXs, gateways, SBCs, all those kind of things. Services, increasingly. And now we've also added online, which at this point in time is relatively narrow from a scope point of view, doesn't yet include the multi-tenant Office 365 capabilities, just the dedicated Link Online capabilities, but will over time increase and capture more capabilities. So those are the 5 pillars, and we'll talk about a few of them. I'll give you a very brief, more visual view of what we do in the audio and video devices. This is the outcome of several years of diligently working with our partners, folks like Plantronics and Jabra and Polycom and others that are listed here, to ensure, and SNOM and others, to ensure that we do have a comprehensive set of solutions that are designed to work and that are qualified to work from the start and optimized, and essentially you're going to get the right quality and the right performance. It's just one of many examples of what we do in that space. Interoperability is not just coexisting with another PBX, it's also ensuring that all the elements of the value chain function properly. That said, typically the program, or the part of the program that's the most relevant or complicated, depending on how we look at it, to our customers, is the one that has to do with infrastructure. How does my Link deployment, especially if I want to do some enterprise voice or some video, fit with the assets that I have? Those IP PBXs, the Wi-Fi endpoints, by the way, this is new. Wi-Fi is, and networking at large, but in particular Wi-Fi is new in this Link 2013 release of the Open Interoperability Program. Why? Because we found out that one of the key sources of poor experience for our end users when they started using Link for audio and video was the Wi-Fi networks. Wi-Fi networks in most enterprises were never designed in the first place to put media on it. It was designed to do some email and some web browsing. So neither the density of the endpoints nor the way they function was optimized for that. We worked with partners, and we actually have at this point one partner qualified, but there's more coming hopefully, that designed and helped us qualify how a Wi-Fi deployment is optimized and actually can be qualified for Link. That's the kind of thing that you can take directly and take advantage of. Same thing for IP PBXs, gateways. Session border controller is also new. And, well, it's essentially an IP to IP gateway. There's not necessarily that much different from a program point of view, but the session border controller can do a lot of other things as well if it wants and if it's useful. So all of those aspects now enable a complete comprehensive deployment from networking to survivable branch appliances to your gateways. And that's all on the Open Interoperability Program page. I'm going to show you a quick view of that. This is, in this case, the one that pertains to infrastructure qualified in the domain of IP PBX and gateways. And you see that for 2013, we're still in the process of filling that up. The test does take a little bit more time. So we RTM'd late last year. Partners are completing their solutions in test right now, and you're going to see much more listed very soon. But in terms of what we had listed for 2010, there's many more, obviously. Changing topics a little bit, I'm going to talk about federation between Link and Skype. That's a special case of interoperability. Yes, you might need to go to the microphone, though. Sorry.
What happens if the versions are not on the list so they're later? What is the cycle? 6 months?
Yes, so the question, I'm not sure whether it fully got through. So the question has to do with what happens when you're using a specific version that is not on this. In most cases, upwards compatibility is going to be okay. Not always. However, if it's not qualified, it's an issue. And then there's so many versions. If it's a small dot version, it's probably not very important. But let's say randomly you go from Alcatel OXE 8 to 9 or 9 to 10 or something like this. This could be fundamentally different. It's even worse if you go from 9 to 8 because at that point, those big versions, there's two things that happens. One is we try and capture them proactively. If we have clear demand from marketplace and customers, we might also accelerate that process. Typically, when we're talking about major versions, it's going to be about 6 months before we have visibility into something announced specifically. So as I was mentioning earlier, switching gears, talking a little bit about Link and Skype. This is a very special case of interoperability because we're talking about interoperability between two products of the Microsoft family now, but a very important one to our customers. And as most of you have heard, I'm sure, we went live last week with federation between Link and Skype. And I have a few pictures to show you how you add a contact in Link, a contact from Skype. Essentially, add a contact in my organization, tap the Microsoft account that's associated with the Skype user. And this is a requirement, by the way. The Skype user must have a Microsoft account. So Skype users that don't have it, we don't have that interoperability with them. And once you've done that, you see that contact in your contact list here. Yes, I can. And you can communicate with that person in the same way as you would essentially with other contacts here. So you essentially right-click, and you can do a link call. We support audio calls at this point in time. The protocols between Link and Skype are still very, very different, and of course we're in the process of working on that, but it does take time to converge those type of things. And at this point, video is not a possibility natively. It would require some significant intermediation and transcoding. There are partners that do that, by the way. I know that Blue Jeans down on the booth shows examples of that, but it would not be practical for us at the scale that we're managing it. So audio is a possibility, and as you see, you can have an audio call between, in this case, Gregory and Jason, between Link and Skype. It's encrypted both on the Skype side and on the Link side. There is, in practice, a back-to-back user agent in between to account for the fact that we're talking about different protocols and different services. That will eventually go away when we have convergence of protocols. I'm going to pause here a little bit because this is the end of the introduction phase, what we do from an interoperability point of view, and also talking a little bit about Link and Skype. And before I switch over to voice interoperability proper, wanted to make sure if there were any questions at this stage. Yes, I may ask you, if you don't mind, to go to microphone.
So I'm curious about Skype calls going the other direction. How would a Link user expose his user ID to Skype users?
Yes, that's a very good question. So I've gone a little bit quickly here. There is a phase, or there's a stage of authorization in that process. In the same way that federation between different enterprises using Link requires that the end user approves the other party wanting to communicate with them, the same thing would occur here. So if I was on Skype and I wanted to add you on Link to place a call to you, I would add your CPRI in my contacts. However, this would not light up. I would see no presence until you've been notified. Might take a short amount of time, and I've accepted that, and at that point, if you've accepted it, I would be able to communicate with you. And of course, this is something that also has a layer of administrator authorization. The administrator might decide to not turn that on at all, obviously. So both administrator and end users. Yeah, go to the microphone if you want.
Is there a way to restrict a group that can only have Skype interop? Is there a way to restrict a group? Let's say, for example, I want my executives to be federated and have IM ability to
Yes.
a federated partner, but we don't want them to get spam or a bunch of requests because they figured out their SIP address.
This is a user policy, so you can decide which users have access to this. However, you cannot once you turn it to Skype, you cannot decide this user in Skype and not that user in Skype. Well, only the ones that have Microsoft accounts will be able to do that, though.
So is there anything on the roadmap to enable Skype federation for classic Skype IDs?
Not at this point that I know of. And there's some value added to this. We believe the Microsoft account will probably also provide us better ways to understand if they were offending users or blacklisting or things like this. Okay, so let's switch gears a little bit and talk about voice interoperability proper. And we'll start with talking about technical strategy, and then we'll talk technical aspects of that. Yeah, so trying to dissociate those two elements. The first thing is really when we say we want to have coexistence and interoperability in voice, I find that talking to customers, there are a lot of different business goals that they are pursuing. In some cases, they have a business goal which is that they're going to progressively or maybe rapidly remove their PBX, their existing PBX. And that's fine, and you can do that with Link. And so the strategy towards interoperability is informed and probably different based on what they want to achieve. In other cases, there is not necessarily a short-term goal of removing the PBX, but they may want to provide new capabilities to some users, such as nomadic voice when they're not in the office. But for a host of reasons, political, assets lifetime, or whatever, the PBX phone that's on the desk might stay. That's okay too. I personally don't care if the phone is on the desk. It might, eventually be a bizarre thing to have two phones and two costs and whatever, but we also have a phone on the desk and a mobile phone, and that doesn't always appear to be a massive problem. What I'm much more interested in is enabling the end users to obtain the right experience when they need it, and for them to, frankly, make the choice of which one they want to use when they want to use it. The same way we do, all of us, with our mobile phone. So those different goals are quite important to understand, and typically when I talk to a customer, I start with trying to understand that. What is it that you're trying to achieve? Not in 5 years, but maybe over the next year or two, because that might actually be quite different in terms of how we're going to go about the strategy itself of the voice interoperability. That's especially the case for small and medium businesses. Let's say you have a small and medium business that's strongly committed to moving to Link Enterprise Voice. Well, we might have capabilities, and we actually do have in Link 2013, where you might say, well, I'm already starting to put Link as your primary call control server. And I'll tell you a little bit more about the technology behind that, which is trunk-to-trunk routing, inter-trunk routing, which we have in Link 2013, which is new. You could actually say, let me put Link as your primary call control. Your existing PBX will be hanging off of Link, and progressively you'll remove it, and that way you'll have your end state from the start, from an infrastructure point of view. On the other hand, if the customer tells me, that PBX is going to be there forever, and what I want is just Link as an add-on, I might do it the other way. Those are the type of things that need to be considered in terms of designing the topology and the infrastructure. In the same way that typically all of us have those two phone numbers, the phone number on the desk or on Link, and the phone number on the mobile phone, I might actually decide that it's okay to have two phone numbers for me in the enterprise. There is a cost associated with that, no doubt. But I know a lot of customers that do that. And how do I reconcile those two phone numbers, and what's the best way to go about this? That might be a first phase before eventually things go away. I have a large customer doing deployment of several 100,000 users that is actually doing this right now. Why? Because they're moving from local, happens to be Avaya call managers, which are locally trunked with local numbers, to centrally SIP trunked infrastructures that is going to be driven off of Link. It takes time to remove all the local infrastructure and to do all the replacement. So they've decided to accelerate the migration from the point of view of giving people the new Link number coming from the SIP trunk. So everybody's going to get two numbers. They'll still have the Avaya phone on the desk, but their hope is people will start using it less, which reduces cost. From an infrastructure transition point of view, they'll have to clean that up for a long period of time because there's a lot of sites. But people can start to take advantage of all the benefits of Link. Don't need to wait or don't need to think of it as we used to do in the old days of PBXs. I replace this PBX with that PBX. It's also possible, but you have different ways to think of it. Now, when people do what we call overlay, which is what I was describing, there's another thing that you can discuss, We're going to give you another line. Do you keep the line you have on your desk? The infrastructure might still be there because the infrastructure needs to do analog lines and faxes and all sorts of other things, which Link can do but just take time to get to. Or you could say, you know what? We're going to keep the infrastructure to serve those things for the period of time it takes us to kind of clean this up. And I'm actually going to put you on Link, you individually, in the same way that if you were a remote worker, you would be on Link. The office remains on the PBX for a period of time while we do that transition. That's yet another way to think of it. So all of those dimensions, they're very important to clarify when you start talking about interoperability from a voice point of view, PBX point of view. There is not necessarily a good or a bad answer. It's more a question of what fits your business need, what fits your goals. Sometimes highly nomadic workforces, the goal might be quick enablement of the end users. That's the kind of thing that we need to understand and that typically are part of the front end of the discussion. So I was talking a little bit about this question of two phones. If you do overlay, you could have, as I was mentioning before, a phone number on, let's say, an Avaya PBX that pre-existed, and a phone number on Link. It's not necessarily a bad thing. However, there's some complexities. One of the complexities is lack of predictability when you start trying to place complex scenarios. Let's say you have a boss on one scenario, or a boss and an admin, a boss admin type of scenario. Boss admin scenarios, they happen to be proprietary. Each vendor does it in their own way. That's not because the vendors are bad, it's just because it's the way it is. There is no real other way to do it. Yeah? And so if the boss and the admin are both using the PBX phone, everything works. If the boss and the admin are both using Link, everything works. If you're in this situation where they're kind of floating between the two all the time, you're going to have broken scenarios. That's also the case for something that people have tried to do, which really breaks very, very much, and that's simulring or forking. I have one incoming call, and I ring both. That sounds like best of both worlds. It's actually a catastrophe because you never know what's going to happen. There are situations where calls get completely lost. One example, a call from Link. Link does a reverse number lookup. So if I call you by your phone number that I expect is going to ring your Avaya phone, let's say, because you have an account on Link, it says, oh, it's actually you. Let me call you as a person. It's never going to go outside of Link because Link doesn't know that the other thing exists. Yeah? It makes it super complicated. And let's say you don't like Link and you don't want to use it, and you're always on the PBX phone. You're looking at your PBX phone, never ringing. And I'm ringing you, it always goes to voicemail. What's going on? That's the kind of thing that really happens in those forking scenarios. So whatever we do here, we want to be super careful about the coexistence and want to try and maintain groups as homogeneous as possible. It's very fine for a work team to say, I want to continue using the PBX phones. No problem. It's very fine for the boss and the admin to jointly decide what they want to do. But once you start having this random thing where people pick it up when they want, and the boss is in the hotel and the admin a little bit more maybe traditional at their desk and looking at the phone, and you're guaranteed to have support calls and it's not going to work. One thing that works very well is permanent forwarding. So you could, for example, say, okay, I'm keeping the PBX phone. It's on the desk. I might put it a little bit further out because my right hand has this, or left hand if you're lefty, has a tendency of reaching out to it all the time, I might put it a little bit further. What I'm doing is I'm permanently forwarding that phone number, that DID, from the phone, from the PBX to Link. And I'm doing that for all users. Now, if for some reason somebody prefers to dial out from the phone, they can do that. It's always there. But very quickly they'll get to clicking to call and it works for them. The advantage is the predictability is that the vast majority of users will not have removed that forwarding. It's possible. If they really don't like it, they can unforward it. But if it's server-side forwarding, you need to do some activity on the phone to remove it. Feasible, but most people won't. And at that point, you have clarity of what the scenarios are going to be by and large. Now, a long-term solution works very well for the transition. That's what we're doing at that large customer I was describing earlier. Okay? This is a reinforcement of the same point, but really to talk about the homogeneous aspect. Really, really important to think of your migrations and your implementations in terms of homogeneous work groups. Now, in most cases, they happen to be physically homogeneous in the same site. That used to be what we did all the time. Now, less and less that's the case. We work with groups all over the place. Thinking of business units in your migration, regardless of whether you do an overlay or not, is actually quite important because that makes the continuity of the business scenarios much more pervasive. So that's a very important thing in terms of who are those people working with? Can we have a homogeneous functioning for those people? Are there any people in the audience who use RCC, like RCC, or want to deploy RCC? Okay. There's still a few hands. Every year, fewer hands. If you're on RCC, it's still supported, so there is no crisis today. Migration to Link 2013 for people who are already on RCC will support you on Link 2013 with RCC. However, no net new deployment. If you're not yet on RCC, don't go to Link 2013 with the intent of supporting RCC. Do you know what RCC is, by the way? Remote call control. It's using Link to control your PBX. We did this. I was part of the team at the time that did this in 2004. At the time, we thought it would last 3 years because we thought we're going to introduce enterprise voice, and everybody would say enterprise voice is so much better objectively. This is just for a short-term transition. People will never buy another PBX. And that was 2004. Of course, people have bought more PBXs, and every year the problem comes back and we do more RCC. No, it's broken. People actually have had massive issues in large-scale deployments. Some deployments function, that's okay. MSIT itself didn't succeed with it, so I'm not saying they're a good operator. That's nobody from MSIT in the room, yeah? But they didn't succeed, yeah? So it's costly, it doesn't work, and also it's very limiting because if you're not at your desk, you can control your PBX phone, but your PBX phone is in your office, and you're not there. So it's not that helpful. If you're on it, as I was saying, you're supported, please make plans to transition away from it. And we can help you explore a lot of other things. Any questions on this section? I'm sorry, I think they're recording, so that's why I'm insisting on the microphone. We probably can bend this. Yeah.
Okay. Is that better? So you have some of your SBA partners that promote dual forking and, so what is your point of view in regards to your SBA partners?
So we love our partners. the point there is you can do a lot of things with Link, or with pretty much any control server, but with Link in particular, and the way we actually give a lot of room to third-party elements in the topology. The question after that becomes, from a business point of view and from a user experience point of view, is that desirable? My opinion, and the opinion of a lot of people in Redmond, is that it's absolutely not desirable. It's actually a very bad thing, and we've seen it in real deployments, and we've gone through the pain of it. Now, I'm not saying that a partner could not deploy it in a manner that works perfectly and that's beautiful. I've not seen it yet, but I'm not trying to say there's room for differences of opinion there. We have deployments that took us through this that make us think it's not ideal. What works very well and partners are doing, and SBCs and gateway partners are doing, is a dynamic dip against the Active Directory attributes to see if the MSRTC SIP, the phone number, the DID for Link, object has been filled. And if there is a number there, say, okay, that person's on Link, let me send the call dynamically to Link, which is a very nice way of operating a migration as well. Okay, let's talk a little bit about some of the technical stuff. Not very deep, but a little bit, yeah? So what has changed in Link 2013? And I've cut that into two things. That's purely my opinion, by the way. People could disagree with that. But I think there is one thing that's fundamentally differentiating from a strategy point of view, especially if you're a relatively small company and you don't want to buy an SBC. SBCs are great, and we love SBCs, but SBCs can be a little bit of a, overkill for a small company. For larger companies, odds are you'll have an SBC, and that's a very good idea. And at that point, you may not need to use inter-trunk routing because they do those things probably in a much richer way than we will ever do. So that feature, inter-trunk routing, I'll talk a little bit more about it in a second, is substantially differentiating from as I was saying earlier, the topology you might decide to use and so on. The rest, it's all super important stuff, but it's likely to be implementation steps and details in some of the choices you do. M2N routing can change a lot of things in the way your gateway and mediation server routing is done, but it's not going to change fundamentally the topology at large, if you will. Calling number translation, that's very useful as well, but odds are if you really needed it, you would have used a third-party gateway to do that or something like that. So nothing that changes fundamentally what you do there. We're starting to get towards IPv6. That's useful, but probably not going to change your life yet. I'm not going to talk much about the useful little things. If you have questions on those, we can talk about those. I'll try. Or we can spend more time afterwards over a few beers. But I'm going to spend a little bit of time on inter-trunk routing. Oh. Well, not quite yet, apparently. I must have changed the order of the slides. One of the points, and we hear this quite a bit these days, is that there are not yet a lot of solutions qualified for Link 2013 in the Open Interoperability program page. And we actually got a first-hand look at that. There were 3 gateways qualified, no PABX, no IPPBX yet, and so on. It's coming, but it's not there yet. So if you're in that situation, you're deploying Link 2013, and you are wondering what to do about interoperability between Link 2013 and your IPPBX, what to do? Well, a couple of things. One, even before this, is odds are that at the Link 2010 functional level at least, what works for Link 2010 works also for Link 2013. You may not get advantage of the new features yet because the partner may not have implemented the new features yet. But by and large, what works for Link 2010 will work for Link 2013 in that regard in terms of, for example, gateways and IPPBXs. Now, if you want to be sure, not just odds are, one way to start is to use a Link 2010 mediation server. So you can deploy a core of Link 2013, but your mediation servers could be Link 2010 mediation servers. At that point, you can use all of the interoperability qualifications from OIP for Link 2010. And once we've finalized the Link 2013 interoperability list, it's never finalized, but once we've populated it more, which is a question of a short amount of time, there's a lot of things in flight, I can assure you, you'll be able to migrate to Link 2013. Of course, if you use 2010, you won't get the 2013 advantages, M2N routing between mediation servers and gateways and things like this. So that's an interesting aspect there. When will my PBX be qualified? Hopefully very soon. We have a bunch of things in flight. I would expect that over the next very few months, you'll see that list grow very substantially. And part of it is that we're doing internal PBX testing ourselves on some of the most important versions. So those we know when they're coming because we're testing ourselves. Cannot tell you now, but soon. This is an eye chart. I'm not going to painfully describe it right now, but for reference purposes, this is what's supported between Link 2010 and Link 2013. So if you want to do that approach that I described earlier of having some Link 2013, some Link 2010, and interoperate at the Link 2010 level, this will help you. I said this is the technical toolkit, so I'm kind of going through things one by one. Direct SIP, most of you know what it is. It's the term we use to encompass the set of SIP-based specification and testing processes and qualification that that enable a SIP talking device, such as an IP-PBX, and Link to talk to each other. And we have 3 elements in that direct SIP list: the gateways, the IP-PBXs, and now new, the session border controllers. The main point of the slide is to make sure that I draw your attention to this. When you see something tested, a lot of customers or partners have a tendency to say, well, it's on the list, so everything works. A little bit more complicated than that. Unfortunately, SIP is not SIP is not SIP. It's not that anybody's bad. It's just practically we all have slight differences, even however hard we try. And some people try harder than others as well. So we test and we see what happens. So for example, in this case, refer is not supported, and RTCP is not supported either. So if you don't disable those, it's not going to work. But if you disable those, what happens is a lot of features that depend on that don't work anymore. So do you really want to interoperate in that manner? Well, it depends on what you want to achieve. In that case, in some cases, it might be very fine to do direct SIP and to disable refer and RTCP and to go that way. In other cases, you might say, you know what? I have this partner that's a gateway or SBC partner that does this super well and actually has more coverage and more manageability of this box. And that partner is actually qualified for media bypass, which we'll discuss in a few minutes. And I actually could do bypass to their box when I cannot do bypass to the Alcatel. I'm not picking on Alcatel specifically. Yeah? So it's actually more interesting to me to have one more hop, even though there is a little bit of cost, because I can do more advanced features such as media bypass and other things. There is no right or wrong answer. That's why we provide you that information. But please do read the fine print, because as frequently the case, there's a few important things there. Oh, inter-trunk routing. Here it is. I think I probably said most of what's on the slide now. Yeah, it provides basic, super basic session management, but sufficient especially for those SMB customers that want to, that probably the SBC is not the choice that they want to have. And that will enable them to manage calls that would ingress into Link that could be distributed by Link to a PBX or to something else. So that's a very nice migration strategy. And let me illustrate that right now on a slide, on a chart. So this is actually a migration topic, a migration story. So you have your PSTN, your gateway. The trunks come into the mediation server. Oh, that's new. Often we had the trunks coming into something else, and then Link would be in the back. Before Link 2013, we would have had the PBX first, and then Link in the back. or maybe a gateway that would distribute based on the DIP that I described earlier, or maybe an SBC. Well, in this case, we're putting the mediation server first. And if the call belongs to the IPPBX, Link will distribute that call to the IPPBX via that trunk. In this case, if this is the topology you want to arrive at, let's say eventually you don't want this and relatively quickly you don't want this, you can start with this topology and progressively move users from here to here and progressively do away with that. And you don't have to change your infrastructure twice and retrunk. So that can be an interesting approach. And this is even more interesting. You can do PBX networking. Let's say you have a bunch of old TDM PBXs, and you want to start, eventually you know they want to go away, but it's going to take time, but you'd like to do some toll bypass, you'd like to run IP on your backbone, but for that you need something to help run it. Well, you could actually do it through Link. Again, this is not the same type of very rich capability you would get with an SBC, and I'm not trying to pretend this replaces an SBC for people who need an SBC, but it gives you this type of capabilities for, in particular, small and medium businesses if you want to. Before I switch to media bypass, any questions on what we've just covered?
So do you have any examples of where this inter-trunk routing would it be good enough, like a real-life examples?
That's a good question. The first one, I have a customer that's doing it, the one on the slide before, that's doing it right now. And it works very well for them. We're talking about, I think in this case, it's a few hundred or a few thousand users, and that's really a no-brainer for them. I don't yet have a customer in mind that does that. Doesn't mean it doesn't exist yet, but Link 2017 has not been out that long yet, and we don't know everything that's out there yet. Great. You want to speak to the microphone?
Sure. So one way that I plan to use it is that I'll have a bunch of SBAs out there, and currently we have the routing table in the SBA. If the call is destined for Link, it sends it to Link, and if the call is destined for a legacy PBX environment, then it sends it via IP to a gateway that goes to a legacy PBX environment. We can completely do away with that table, send everything to Link, and then have Link send the call to the legacy PBX via the gateway that way.
You want to tell everybody the company you work with and what you do with Link?
I work for BNSF Railway, and I'm the UC architect for BNSF.
Thank you. More questions on this section? So let's talk a little bit about media bypass. Media bypass has not changed dramatically from what we had in Link 2010. I'm going to review that quickly, a little bit quicker than we did in previous sessions, but because it's such an important part of the interoperability with IPPBXs in a distributed topology with branches, I think it's worth to remind people of what it is. Actually, I should do a quick show of hands. Who's comfortable that they understand media bypass? Probably about a third or so. So I'll still go through it. I apologize for people who understand it. So this is the very simplistic conceptual view of media bypass. Yeah? Essentially, in Link, talking to an OIP qualified Open Interoperability Program IPPBX, so we're going to have a SIP trunk here using direct SIP. The signaling is always going to go through the Link pool, always going to go through Link server. Actually, it's always the case in Link all the time that signaling always goes through the server. On the other hand, you have the opportunity to get the media to flow directly from the Link endpoint to the IPPBX. I'll be very specific, never to the IPPBX endpoint, and I'll go back to that. It's the Link endpoint talking to the IPPBX from a media point of view. It's not endpoint to endpoint, and there's practical reasons for that. We can talk more about that if needed. The advantage is, and I'll show you more charts for that, but let's say that the Link endpoint is in a branch, and this box is in a remote or in a central office. You don't need to backhaul back and forth on trombone on on the WAN, the traffic can stay local. And I'll show you a little bit more how that works in a second. Those are the benefits. It frees the media from the mediation server, less latency, less management, less CPU you need to churn. The media is better quality as a result as well. We can do this based on the location. So it's dynamic based on the actual real-time location. And we use the same infrastructure for that as call and mission control, by the way. So if you're familiar with the way call and mission control works in Link with subnet information and so on, that's what we use. And in particular, that enables us to have a much lighter, much smaller CPU-wise mediation server that mostly deals with signaling, which is great if you want to have it in an appliance like FormFactor or co-locate it with your front ends. So what do you need? Well, you need a peer that supports bypass. And as I was mentioning earlier, many of the IPPBXs don't. Now, there are IPPBXs that support it. In particular, most of the Cisco Unified Call Managers of reasonable versions support it, which is great because that's a lot of them out there. But as we saw earlier, Alcatel, that won't work, and there's a few others that won't work. Yeah? So very important to have that. Now, all the SBS support it. Most of the gateways today support it. Most of the SBCs support it, so we're fine now. You're going to need on the PBX side a centralized media processing point, which is where we actually aim the media coming from our client. Why we need this? If all calls were just simple point-to-point and never forwarded, we probably would not need this. However, what happens is if you place a call and then that call gets some sort of forwarding, gets some sort of put on hold or whatever, odds are we're going to lose both call control server will lose complete control of the call and will no longer understand where the call is at, and the call will fail. So some people have tried to do it with bypass directly to the phone. Could you arrange it? Yes. Is that recommended? Absolutely not. It's not supported. And when you test it with simple cases, it appears to work. And then once you start having it in production, it's a lot of pain. So don't do it. One little point. It's one of those domains that probably is the most technically complicated in the entire set of things you can do with voice with Link, because it requires that you understand your peer system, your IPPBX fairly well. You understand what you can do on Link very well. There's some network elements. There's resiliency aspects, routing aspects, and so on. So this is one where having somebody who knows what they're doing, hiring somebody might be a good idea. How does this work? Well, this is the topology we're going to use. We have a central site, and both the Unified Call Manager, Cisco Unified Call Manager, and Link pool are implemented in central site. Then you have branches. In those branches, you're going to have, for example, an ISR from Cisco, and that ISR has a card, which is an MTP, media termination point. And you have Link clients. And we're going for now to assume that the WAN is resilient, so we don't have to worry too much for now about resiliency. We'll change that in a second. And I apologize, I'm showing one side. I only have one way to point at the same time. It's not practical. Sorry about that. So first, if we have a call that goes between Link client in the branch and a Cisco endpoint, and I'm picking on Cisco here because it works very well with Cisco. There's others that could be the case as well. Yeah? Link in the branch and Cisco in the headquarters, we're going to go across the WAN to the headquarters. Now, this is not a situation where we want to bypass. Why? Because we're going across the WAN, we would actually like for this call to be using RT audio. We would actually like for this call to be managed with the best possible quality management. The mediation server, one of its roles is that it does media healing. So if there was damage of the media on this leg, we actually want to use a mediation server for that media healing. So we're not bypassing that call. We're going to use RT audio here, we're going to transcode, and we're going to use G711 here, and then to the Cisco endpoint. On the other hand, if you're in a branch situation, let's say banks, lots of banks broadly deployed with thousands of branches, typically very poor connectivity, the signaling will always go to the headquarters. Again, let's assume for now that the WAN is resilient. Yeah? So you have the same ISR with an MTP. A signaling goes here, goes to call manager. Call manager will instruct the ISR and the Cisco phone to establish the call. The media remains in the branch. No media tromboning across the WAN, which means that you can actually deploy just clients in this case in the branch, do that overlay scenario I was describing earlier, and coexist phones and link, and the media will remain local. And this works even if you have many, many branches and many ISRs and one single control point. There is literature out there from Cisco that suggests that it doesn't work. That's mistaken. So it does work, even if you have multiple gateways and so on. Interestingly, we actually don't need to know in advance even the IP address of that gateway. All we need to know is the range of IP addresses in this branch, the subnets. Because we're going to use dynamic signaling in SDP to actually send the media to the gateway. So that's actually a quite interesting thing. You could actually have your Cisco team managing the gateways, changing the IP addresses, redoing it. I need one more ISR, I need one less, whatever. This one's done. We don't need to keep any sort of table on the link side of that. There is no duplication of that architecture whatsoever in link. We just need to know that there is a range of subnet, and that range of subnet is actually going to be mapped to gateways here. And once we receive the dynamic IP address from the Cisco side, we'll be able to route to it. So actually quite smart from a system point of view, from an operations point of view. If you needed to manage a table in link of the Cisco infrastructure, that probably would not be manageable at all. Let's talk a little bit about a case where we have a WAN failure. If the call was up, the call stays up, the signaling is done, we have signaling resiliency, so at this point the call stays up. But you cannot establish a call in this case. However, we could actually have here a survivable branch appliance, which I don't have. I thought I had one more slide. So if we had a survivable branch appliance in this branch, so at this point you deploy both link clients and a survivable branch appliance, we could establish the calls within the branch through this. We could actually even use the ISR as gateway for PSTN egress. So you could actually have a completely resilient topology, one down, link server being here, an SBA, an ISR, local bypass, the media remains local, and we could use the ISR for egress, ingress and egress of PSTN. And that's the type of deployment we now have. There's a number of large companies doing this at this point in time, in particular one in Houston that is implementing this. Very large. Questions on media bypass? There's a lot of reference slides here. I'm not going to detail them for you, both from a time management point of view, and I think it's kind of dry and thick. So I'll pass on those slides, but want to take questions if needed.
So in this last scenario, that ISR will be defined as a PSTN gateway in the topology, right?
It doesn't have to be a PSTN gateway. Sorry, no. I mixed two things. One, if we want to have egress and ingress, it would be defined as a gateway, independently, by the way, of the bypass.
Yeah.
Those two things are separate.
Yeah.
So thank you for catching this, because I probably confused everybody by adding the ingress-egress. Those are completely different problems. We could use this gateway as a gateway, defined as a gateway. In addition, it can be used for bypass, in which case it doesn't need to be defined in advance. Thank you. Other questions on bypass? Great, it's this time of the afternoon. And I know it's, as I was saying earlier, interoperability is important, but it's like accounting, it's not the most exciting stuff in the world.
How is this affected with a cloud or a hybrid cloud environment? So maybe get into that a little bit.
That's a great question. In the short term, and I think I don't know that we have a lot of sessions on cloud, link online here today or these days. At this point in time, the way we are positioning our offering, and that's going to change over time, is that if you want to do this type of things, you should be on-prem. So that's clear from the point of view of today. We absolutely are committed and actually have put out some milestones back at the Link conference. There was some announcements of roadmap and intent in terms of voice in the cloud. However, as of today, we do not have this type of capabilities in the cloud. I think it was mentioned that, Vivek, I think it was mentioned that we wanted to have a voice offering in the cloud in 18 months. Yeah. I see Vivek nodding actively.
Could you explain again why you need the media termination point and why you can't go directly between endpoints with an RTP stream?
Yeah. So since you're asking, I'm going to share with you some ugly truths as well. There's two reasons. One is the one I mentioned, which is a real technical reason, which is that if you were to establish, let me try and go back. Yes. So let's say that you have this call in place, and now this guy, never mind, says, you know what, I want to start a conference call. I want to bring one more party into this call, or I want to put this call on hold, or I want to do a consultative transfer. All hell breaks loose. There's another one, which is our little secret here, which is that there is about an infinite amount of endpoints, and they're all a little bit different, protocols and whatever. And testing against that is a nightmare. And there might be something that might work somewhat somewhere, but it's almost impossible to find the right one. So I've seen some people try it, as I mentioned earlier, and as long as you do very, very simple calls and don't ever try to do any sort of, anything else but peer-to-peer, it kind of appears to work. But in practice, it doesn't. Now, the vast majority of those ISRs have the ability to run an MTP in software. And we don't need that, depending on the size of the branch, you don't need a lot of stuff. And of course, there's cards as well if you needed something bigger. Okay? So as mentioned earlier, I'm going to pass on the text slides on media bypass and talk about something a little bit more new, interesting, and exciting: video interoperability. We have a lot of new things in Link 2013 with respect to video. Actually, if I was to mention the most changed thing across all the things we do in Link 2013, it has to be video. What we want to do, and we're very strongly committed to it, provide high-quality video, not just in every desktop, actually, on every endpoint. The meeting room is a very important one. For those of you who visited our booth, you've seen the Link room system. We actually have a Link room system from Crestron on the booth. We have four partners that have announced the Link room system coming up very, very shortly. We've RTM'd that, so the bits are done and it's available for sale. I was hearing earlier that there is more than 80 already pre-ordered and being shipped, and so it's working very well. The Link room system is a perfect example of an application of what we do in video that's very new in Link 2013. But the third component of video is interoperability, because there's a ton of video rooms out there. They represent significant assets, both from the point of view of the physical assets and the money that was invested in them. And it's just not right to come in and say either do things remain separate or do things go. We just understand that's not going to work. We had ways to work with those conference rooms before. And in particular, we have had a video qualification program for several years, I think for more than 5 years now. But it was very difficult. Why? Because in most cases, we needed to transcode the video in order to get something between the room system, the VTC, and Link, until Link 2010. So all of those things remain valid, but a lot of those things do, not all of them, but a lot of those things do transcoding, and when we do transcoding, it's expensive and not scalable. A lot of the other things use the codecs, implemented natively the codecs that we actually were using before, RT video. The way we do it now is completely different, and I'll tell you a bit more about that in a second. This is a brief recap of some of the salient points of what we did and was still do in video in Link 2010. So we were supporting HD 720p. That required quite core, so somewhat expensive. We supported 2 codecs, H.263, which is a very bad codec, but at least had the good grace of being present in many places, and RT Video, which is a Microsoft codec. And we attempted to standardize it and to get an industry adoption around it, and we had some partners work with us on this, but practically from a number of endpoints enabled, that didn't really work out the way we wanted. We did panoramic video, and we continue to do this. From a multi-point point of view, same thing, RT video, but only up to VGA. We were not able to do it in high definition. And we were doing active speaker switching only for multi-party experiences. So if you wanted to see multiple participants' video at the same time, you could not. In Link 2013, lots of innovation. So full HD with smaller CPU requirements. We still support RT video, but we now support this new codec, H.264 scalable video codec, which gives us that full high definition. We also support panoramic view still. From a multi-point point of view, still RT video, but again, H.264 SVC, and we go multi-party from VGA to full HD. So now we have in AVMCU, in software, the ability to do multi-party, multi-view, simultaneous streams, 5 active speakers, 5 simultaneous video streams in full HD with high scalability, again, all of that in software. So drastic change in terms of the capabilities. But that's not the only thing that's new in terms of what H.264 brings us. We also now get the ability to support mobile clients. Mobile clients, typically, all of them have a form of H.264 available to them in the chipset. In Link 2010, we did not have the ability to do video on those devices because RT video was not implemented, and of course, they didn't have the CPU required. Now, in Link 2013, both with the Windows 8 client and Link 2013 mobile, we have the ability to do video, in some cases, up to high definition, depending on what the device supports, including gallery view, multi-party, up to several, I think it's 5 in this case as well, might be 4, simultaneous speakers on the device, on the Windows 8 RT, on the Windows RT interface. So complete change of our video capability on devices. What about interoperability in all of this? Well, it starts with SVC, scalable video codec, and we need to recognize the way this was attained. This is an industry effort, and this is an industry effort in which, in particular, Polycom had a significant contribution. Others as well, video is another one, and there's quite a few people who contributed to that. This was federated at the USIF, Unified Communication Interoperability Forum. For the past 3 years, we've been working together in the USIF around scalable video codec, H.264 scalable video codec, making it the default codec of the industry. Essentially, every player that's at the USIF, which is pretty much every player minus one, is committed to H.264 SVC, is implementing it. And that's not just software vendors like us. It's also chipset vendors. It's also end-to-end solution vendors. It's also cloud solution vendors, such as BlueJeans and others, and video. So it's quite important to think that now the entire industry, asterisk, is completely converging around this codec, which is going to give us a lot of performance, a lot of capabilities in software at low cost, and it's also working with the mobile devices you own. One of the very interesting things of H.264 SVC is that it has backwards compatibility. It's compatible natively with H.264 AVC. H.264 AVC is the codec that exists in most cases, virtually all cases, in your conference rooms today, in your VTCs. Whereas before, I was mentioning when we wanted to interoperate with a conference room between Link 2010, we needed to transcode. H.264 SVC natively now gives us the opportunity to interoperate without transcoding, which completely changes the cost of that interoperability. Interoperability through transcoding gateways, some of them are several $100,000, literally. And that's only maybe 20 flows or something like that, 20 streams. If you want to enable thousands upon thousands of your employees to do video, you can't buy that. So transcoding is just a complete impossibility in that space. Would just not work. By using H.264 SVC, we get backwards compatibility to all the mobile devices out there, because they use H.264 AVC typically, and most of the standard-based rooms that exist today. We're also removing H.263. H.263 is a CIF codec, so it's a very small resolution codec, a low quality, and we have a much better alternative with H.264 AVC interoperability between AVC and SVC. And if we need to do backwards compatibility with RT video capable points such as Link 2010, we can do that because we still carry RT video. There might be some extremely rare cases where the VTCs don't have H.264. Very, very few of those out there, small proportion. For those, there are partner solutions available today. BlueJeans is a good example for that. And others, gateways and so on. So our interoperability, now that I've described what we did, our interoperability direction is really centered around H.264. And I'm using H.264 here deliberately without putting something behind it, because we'd love for it to be SVC, but if people don't have SVC, AVC is okay. Or you also occasionally hear baseline. All of those, different terms, slightly different concepts, but about the same thing. So H.264 is what our going forward interoperability is based on, because we don't want to transcode. On the other hand, signaling is something that needs to be worked with partners or will require gateways. It's not a problem because signaling gateways scale very well, are not expensive, and actually we're building one. So I'll talk to him a little bit more about that. But doing something on signaling is not going to be a problem. Why do we need the signaling? Well, for things such as the fact that we provide 5 simultaneous streams. How do you get to interpret which of those 5 streams you receive and so on? Well, that's in our signaling documentation, which, by the way, is on that Office protocol documentation online that I described. So if you want to build something to that, a gateway or whatever, it's available. And all of this is also continues to be centered on the USIF. So we continue to work very diligently together with our partners at the USIF to make sure that going forward, not just the one-time thing, but going forward, we maintain that interop. So those are the main pillars of our interop from a video point of view, starting with Link 2013. In that context, there's going to be 3 types of systems out there. There's going to be qualified systems. Those qualified systems will essentially have the ability to do what Link does pretty much natively. And there's a lot of very rich requirements around that. A lot of systems will not be able to get to that. There's compatible systems. They will need some updates from a signaling point of view and transport protocol and so on, in particular encryption also, SRTP. And real-time video is required as well for backwards compatibility. A lot of the existing systems from our partners that were done for Link 2010 will fall into that category. And we could interoperate with RTV, with H.264 AVC, or with H.264 SVC with those. Then there's standard systems. Pretty much all the systems that exist today, or all the systems from the people who are not part of the same group, if you will. And those standard systems, they're not going to support the same protocols. They're not going to support the same codecs. Well, they might support H.264 AVC, but certainly not RT video. So in practice, there's going to be a need for a gateway for that. Both our partners, third parties that are not necessarily our partners, and us are working on that at this point in time. One specific case is Cisco interoperability, so Tandberg rooms and Cisco rooms. And at the Link conference in February, we announced that we are committed to supporting that interoperability. So we're building a solution for that. Now, Cisco might also have a solution, but we're building a solution for that. I see some people are happy. That's great. So this is going to be primarily, that video interoperability server or gateway is going to be primarily for the purpose of signaling intermediation. That said, in some rare cases, there might be some transcoding occurring on it. Yeah? in particular if there is RT video on one side, like Link 2010 and H.264 on the other. No, that's the only way we can do it. So that's coming. I don't have a time frame yet. Don't ask me, I don't have it. But soon. Those are my last 2 slides, and then we might have 3 minutes for questions on video. Good. Pretty much just in time. Those slides are a little bit complicated. I need to give credit to Jeff. I don't know if he's in the room. Jeff Schertz from Polycom. Not in the room, but still credit. I'll try and do justice to the slides. This is peer-to-peer scenario for now. So we're talking about not multi-party, just one-on-one scenarios. You have some Link 2013 clients. You have Link 2013 servers. You could have qualified gateways, as I described earlier. And then you have the 3 categories of systems, the qualified systems, which pretty much act like Link, the compatible systems, which are very close, might have RT video implemented, but typically not like Link, and then the standard systems, which are typically completely different. Might be your existing 10-block system. So first, qualified system, point-to-point, super easy. We do H.264 SVC between them, no problem. This acts as if it was Link. The compatible system, multiple options. Of course, we can do real-time video, RTV, because those support RTV, and this has RTV as backwards compatibility. Or if they have implemented H.264 AVC, we can also do H.264 AVC. Typically, that's the case as well. There are some pros and cons on either side. We'll be able to support higher resolution on the H.264 AVC, in particular, full HD. Standard systems, that's where, in many cases, we're going to need to transcode. If the Link client here uses RTV, for example, if it's a Link 2010 client, which could be the case, then we only have RTV. Then we're going to need a transcoding gateway. And that transcoding gateway will talk in H.264 AVC to that standard system. So there's signaling and transcoding happening here. On the other hand, if we're able to use H.264 SVC or AVC, then that gateway will not do transcoding, will do signaling intermediation. In rare cases, it might do transcoding if the resolutions are not matched or there's something wrong, but typically it won't. So that's for peer-to-peer, I think. Yeah. Now let's talk about multi-party. So if you have multi-party, for example, you have a qualified system here and a Link 2013 client participating in an AV MCU hosted conference. Everything is in H.264 SVC, everything's beautiful, no problem. You might have a compatible system joining. That compatible system is not capable of doing SVC at this point in time, so it might actually do RT video. And we'll do some transcoding on the AVMCU in that case. That's seamless to you, but we'll do transcoding on the AVMCU. Of course, at that point, what would happen is, well, actually, I take back the transcoding. In this specific case, we don't need to do transcoding. We're actually capable of rendering the RT video stream directly. So we would not do transcoding in this case for RT video. My apologies. The standard system, if it joins at that point, it's getting some RT video. This needs to be transcoded here. On the other hand, if it's getting some H.264 SVC, depending on who's the active speaker in this case, no transcoding. So this shows kind of the range of, we have different systems, qualified, compatible, and standard. We'll be able to function with each and every one of them. There's going to be some differences. In some cases, nothing in between, complete flow, no problem. In some cases, you'll need a gateway. That gateway might, in some cases, need to do transcoding if you have RT video. Otherwise, it won't do transcoding. It's just pass-through. Media relay is the term. With this, I have concluded the slides and happy to take a few questions.
So quick question, where do you see WebRTC fitting into that last round of architectures there?
That's a great question. WebRTC, from a video point of view at this point in time, uses a completely different set of, well, not set of one, completely different codec, which is not today in the enterprise. So the enterprises typically don't have that codec implemented anywhere. Well, it might be in a browser somewhere, but it's not in the enterprise infrastructure. So WebRTC today, if it remains the way it's specified, would require transcoding, which is obviously a very significant industry problem. Microphone, please.
Two parts to the question. First, what is the future of Link Phone Edition, and how does the impact of H.264 and RT audio, the audio portions of these codecs?
I didn't hear that. Can you speak in the microphone, please? The last part.
How is the audio codec situation impacted by what's happening with Link Phone Edition?
Yeah. So the Link Phone Edition question, Link Phone Edition continues to be supported, and it's going to be supported for a very, very long time. We now have partner solutions that are compatible phones that are increasingly richer from a feature set than the Link Phone Editions. And we see more and more of our customers use the compatible phones instead of the Link Phone Edition, and we understand that as well. It makes sense. We also believe that there's less and less pure phones being used. When you can buy a Surface for $99, well, that's a unique case, but why would you buy a phone for 200 or 300, yeah? So when you put all those things together, I would say that more and more emphasis is going to be on the compatible phones. It doesn't mean that the Link Phone Edition goes away. With respect to the audio codec, a lot of this can be either G722 or RT audio, depending on what's supported on the other side, and typically that's not a problem. Audio is much less of an issue, and even if we needed to transcode audio, that's a relatively inexpensive activity. By the way, I'm over my time, so if people want to leave, they're more than welcome to, but I'll take questions as long as I'm here and not kicked out.
Yes. One question is, with Link 2013, you support H.264 SVC, but why don't they inbuilt also the standard signaling that is already defined in the H.264 and H.323 standard?
Yes, so the question, if I understood it correctly, is why did we extend the signaling? And we extended the signaling because we wanted to provide value-added features, such as the ability to select which person you would want to watch, or viewing multiple people at the same time. In order to do those type of things, there's just no standard. Now, we're publishing those standard extensions, and we're welcoming people to use them. That's not a problem. And this is not incompatible with the signaling. It's an extension. So if people want to ignore it, that's fine too. But it's important to understand that we are trying to do more value add for our end users than just the one video. We want them to be able to watch multiple streams, to select the stream they want to watch, to have active speaker in some cases. That's the kind of thing we do through those extensions.
Multiple streams has been in the standards long before Microsoft came into the market. So
that is correct, but that's static multiple streams.
No, it is both sharing issues and sending the video streams in dual streams. That's no problem.
Yes, so I understand what you're saying, but the type of things we're doing in that domain of multiple streams, I can assure you that's not in standard, that goes beyond the standard capability. And that's typically the way standard function anyway, that people use them as a base, but there's going to be, this is a competitive world, and people won't buy plain solutions that just do the plain standard typically. We need to extend them, and all the vendors do that. It's not a bad thing. I think we're done with questions. Thank you very much. I appreciate your time. Thank you very much.